download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is on resistance and Ohm's law. Now, Ohm's law states that the current through a resistor is proportional to the potential difference provided that the temperature is constant. So what does that actually mean? Well, if I draw a graph to describe what I'm saying, we're going to draw something called an IV graph, okay, i.e. a current voltage graph with current along the X, okay, representing I, and voltage or potential difference along the Y, which is V, and that's why we call it an IV graph. Okay, now Ohm's law states the current through a resistor is proportional to the potential difference provided that the temperature is constant. So that means that as the current goes up, the voltage goes up as well. So our graph looks like this and is a straight line. We can see that as the current goes up, the voltage increases as well. Now, if an electric component has an IV graph, remember a current voltage graph, that is a straight line, i.e. this graph here, a straight line, then the component is an ohmic conductor. Okay, so if a component has an IV graph that is a straight line, i.e. it's showing proportional, so it's showing that current is proportional to potential difference, i.e. it will be a straight line, then the component is an ohmic conductor. So any component that has an IV graph that is a straight line is an ohmic conductor. So for a resistor, the potential difference is proportional to the current, provided that the temperature is constant. And the graph for a resistor, the IV graph for a resistor, remember looks like this. Okay, so as our potential difference or our current increases, so does our voltage. So they are proportional, which means that the resistor is an ohmic conductor. So it is an ohmic conductor because it follows Ohm's law. Okay, because the line is a straight line, i.e. as the current goes up, the potential difference goes up, they are proportional to each other, therefore the resistor is an ohmic conductor. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, a filament light bulb does not follow Ohm's law, so we say it's non-ohmic. So if we were to draw the graph for our filament bulb, it would look something like this. As the voltage increases, so as the voltage goes up, the temperature of the filament bulb will increase. And we know that if we increase the temperature, then we're also increasing the resistance as well. Okay, so the current will therefore start to slow and it will look like this here. Okay, so this is a graph for a filament light bulb, and because it is not a straight line, it is not an ohmic conductor because it does not follow Ohm's law. So do remember the shape of this graph for a filament bulb, and do remember that it is not an ohmic conductor. Now, an LED is also a non-ohmic conductor and only allows current to flow in one direction. So the LED will only work if the current flows in the right direction. So the graph, the IV graph for our LED, and we'll change the colour so you can see this happening, looks like this. Okay, so our IV graph for our LED looks like this, and it's not a straight line. Therefore, it is not an ohmic conductor. What I'd now like you to have a go at is answering these questions here, and then we'll go through the answers together. So pause the video now. Okay, so let's go through the questions. So number 1, A, this is your symbol for your resistor. B, here is your lamp. C, here is your LED. D, here is your thermistor. And E, here is your LDR. Now, it's always a good idea, remember, to continually test yourself on these circuit symbols to make sure you remember them. So, using the graph, at what voltage does the lamp stop acting like an ohmic conductor? I.e., when does it stop following Ohm's law and being a straight line? Well, it starts to curve at around this point here, and if we go down to our voltage, it's 4. So it's 4 volts is the answer for that one. And finally, why does this happen to the resistance of a lamp? So why does the current start to gradually go like that? Well, it's because the filament bulb gets hot. Okay, and we know as the bulb gets hot, the resistance will start to increase. Okay, so it's because the filament lamp bulb gets hot. So we've now looked at Ohm's law and what we mean by it, and we've looked at a resistor, a filament bulb, and also an LED, and we've seen that a resistor is an ohmic conductor, whereas a filament bulb and an LED do not follow Ohm's law, therefore are not ohmic conductors. You can now test yourself using the quiz and answer any exam questions on the topic. If there's anything you don't understand, then please get into contact with one of our tutors who will happily help.